Okay, for example, 3 of the unusual solution sets. Just like before, we're trying to find where this polynomial x squared plus 5x plus 7 is less than 0. And so we need to find our x-intercepts and our vertical asymptotes. Well, when I go to find my x-intercepts, I need to see where is this function equal to 0, polynomial, not function, equal to 0. And therefore, we need to see if we can factor it. But is there anything that multiplies with 7 that will add to 5? No, there's not. So therefore, how else can we solve this? Well, if you're thinking quadratic formula, you're correct. So remember on this one, a is 1, b is 5, and c is going to be 7. And so do you remember your quadratic formula? All right, so let's see if we can remember that. Okay, now that we've recalled our quadratic formula, we can go ahead and start plugging in. So we get x equals negative b plus or minus the square root of that b squared minus 4ac all over 2a. And so as we work this out, we get negative 5 plus or minus the square root of 25 minus 28 all over 2. If I keep going, I get negative 5 plus or minus the square root of negative 3 all over 2. Hopefully warning bells are kind of going off because the square root of negative 3 we know is an imaginary number. Therefore, that means that there are no x-intercepts. So my x-intercepts would be none. So if it doesn't cross the x-axis, where is it going to be less than 0? Well, we got to think about what we know about quadratics here then, because that means either this graph, when it's graphed, is all above the x-axis or it's all below the x-axis. Since it doesn't cross it, it's got to be one place or the other. Well, from what we know here, our leading coefficient is positive, so that means that, or the x squared is positive, therefore it's going to be opening up. So if it's opening up and it's not going to cross that x-axis, that must mean that it is above the x-axis. Well, we know all the numbers above the x-axis must be positive numbers. Therefore, is there anywhere that it's going to be less than 0? No, there's not. Therefore, we can safely say this one has no solution, or we can say it's the empty set. Whichever way you prefer to write it.